Welcome back to Calculus 3. We are in section 2.1, 2.2 again. It's the introduction of vectors. And this is my note. And actually, I try to list out some basic things, the arrangement for the two-dimensional plane and the three-dimensional space. In many ways, they are similar or they are similar arrangements. Okay, the two-dimensional plane and the three-dimensional space. And in the two-dimensional plane, a point, it is an ordered pair. And then in the three-dimensional space, a point, it is an ordered triple. So you see they're different, but anyway, certainly they are related. They follow the similar arrangement. And also the way to understand the equation in the two-dimensional space and the three-dimensional space. I just put one simple example, extreme simple example here. X equals 1 in the two-dimensional plane, it represents a vertical line passing through the point x equals 1 on the x-axis, right? And x equals 1, well, without mentioning two-dimensional, three-dimensional, those signs, you may want to say the order sign. But anyway, if we are considering the three-dimensional space, x equals 1 really represents a plane, which is 1 unit in front of the yz plane. And if you know the arrangement, how to draw the rectangular coordinate system, 3D space, you probably know what the yz plane is, right? The yz plane. Okay. And also, this is a good thing. Actually, I did not see the textbook mention this part specifically. It is a midpoint between two given ones. So the midpoint, it is giving us the x coordinate as the average of x coordinates. Y coordinate, it is the average of y coordinates. In the 3D space, really I can state in the same fashion. But anyway, keep in mind, in the 3D space, we are having ordered triple, right? So also we need to consider z coordinate. But anyway, in words, really the sign. The z coordinate, it is the average of z coordinates. Okay. The distance formula between 2 points. This is in the 2D, that is in the 3D. Okay, and then for the equation of circle, hopefully we covered it in, I guess, in algebra, in pre-calculus. You know that very well. And then we will have to deal with the equation of circle in the 3D space, but anyway, somewhat it's more complicated. At the moment, we look at a similar arrangement for the equation of a sphere. Because I'm saying they are perfect squares, right? Instead of 2, we are having 3 perfect squares. Okay, add those 3 perfect squares. Indeed, they generate one circle, but anyway, they generate many circles. There are many circles. So overall, that tends to be a sphere, not only a circle. And also, it's worth to mention, in general, you can consider the equations in a plane, 2D plane, would represent a curve. And the equation in a 3D space would represent a surface. Could be a sphere, could be a plane. And also, if you read the textbook, you see we could have planes, right? Okay, so 2D, 3D. And also, let's look at some simple case, linear lines in the 2D space. That is a very common form. I suppose you know this very well. And this is called as a linear equation. And indeed, we may also have linear equation in the 3D space. And indeed, this type of equation, it is not just a single line. It would represent a plane. And we'll talk about the lines and the planes more after the discussion of vectors. And speaking of vectors, I have a little more content about the vectors over here. Vector I and the vector J. These are the unit vectors in the two-dimensional plane. And a vector, it is an ordered pair. You can use ordered pair directly. And also you can use the so-called linear combination of unit vectors. They are equivalent. And similarly, we can make the same arrangement for three-dimensional vectors. Even though we are using same notations, especially for I and j. But anyway, I hope you see I here is really different. Okay, the I in the three-dimensional space really will not mix with the two-dimensional I. Same for the j, and certainly there's no k in the two-dimensional plane at all. Okay, but anyway, we do use same notation, and the reason we use same notation because in words really we can say the same thing. In the three-dimensional space, I it is a unit vector in the x direction, then in the y direction, in the z direction, and also similarly we can consider this vector u in the component form or the combination of I, j, k, I, j, k. Or maybe we take a quick look. I think this is the checkpoint 2.15 from the textbook. And take a quick look. I mean, this is the same kind of example we did on the textbook. We want to find out the equation of sphere with diameter p and q. P it is given such, or maybe I'm going to change the line here. P it is an ordered triple. That's a point. Okay. And again, if you wonder when we consider ordered triple as a factor, when as a point. For now, let's say if you have an ordered triple included with a pair of round parentheses, that's a point. And if you have an ordered pair, ordered triple included with angle brackets, then that is a vector. So clearly P and Q both here are for points. Okay. And the center of the sphere, it is a midpoint. So you want to use the midpoint formula to find out the center first. This is how I get the center, and these are the center. And also the radius, well, I'm going to say this time, the radius I calculated here, it is simply starting from the center. Either could be from the center to P or Q. What I did, I just calculated radius as from the center to Q. So this is my calculation. Hopefully, I guess the number should be all right. Okay, if you have any question or if you feel something not right, just let me know. And then I try to copy the formula again using the equation, standard form of an equation of a sphere. And then we have ABC, that's for the center. And the radius, that's right here. So square root of 14 squared, that's just 14. This is r squared, this is r squared. Okay. So far so good. Let's go a little bit further. Do vectors. On the textbook, we already covered two-dimensional vectors and three-dimensional vectors. I feel it should be easy for us to follow. Indeed, we could define high-dimensional, any-dimensional vectors. So in general, we say a vector, it is an ordered n tuple. And if you have 10 tuple, that is for 10-dimensional space. And mostly, we are just going to consider two-dimensional or three-dimensional vectors, okay? Like we covered on the textbook. And also, a vector in the two-dimensional, three-dimensional case can be considered as a quantity with magnitude and direction. So the magnitude can be calculated as this is absolute right notation. It is used to denote the magnitude of vector. It is the square root of sum of squares of all components. All components, that's the magnitude. And then if you need to have a vector in the, well, a unit vector to give a direction. Okay, so the unit vector always can be found multiplied by the reciprocal of the norm of the vector to vector itself. And also a vector, usually it is an ordered tuple, okay, ordered pair, ordered triple. And then in the case, what would happen like a two-dimensional case, three-dimensional case, we have a vector given by 2 points from point P to point Q. And then the vector can be found by arrange the difference of the corresponding components together. as an ordered, in this case, ordered triple. Okay. And the vector operation, as we covered on the textbook, there are two operations to consider. Vector addition. Algebraically, there's really not a lot to worry about the vector addition. We simply generate a new vector such that the component, it is the sum of the components, right? U plus V. We add U, V together in the component wise fashion. And the scalar multiplication, we multiply each component by the same scalar quantity. And actually, I did take an example from the textbook. Check point 2.910, V and W. I suppose it really should be very simple. It is to find a unit vector in the direction of 5V plus 3W. Mostly, I would say in general, for any math problem, it might be hard for us to jump to the conclusion directly. So you do need to show the work. So first, what I calculate here is the vector 5e plus 3w. And still, you want to help me double check my numbers. And for now, honestly, when I'm reading the notes, it's hard for me to figure out if numbers are right. Okay. Hopefully they should be fine. This is the vector. And then remember, this is how we make the arrangement for the unit vector. We multiply by the reciprocal of the norm, right? So after done with the vector, I also calculated the magnitude. Then I multiply the reciprocal of the magnitude to the vector, and which is giving me a new vector. And you want to give a try to see indeed if it is a unit vector. Of a unit vector, it is a vector with length 1, with magnitude 1. Okay. So I believe that's all I have for section 3.1 for now. Hey, thank you for watching, and hopefully you will see me again on section 2.3. Thank you.